So let's suppose that we're being asked to construct a confidence interval for a population parameter which we don't know. And this, for example, could be the population mean. We're quite interested in finding out the population mean. We don't observe the parameter, we just observe the corresponding statistic, which is the sample mean. And so I want to outline a 3-step process to construct a confidence interval given the relevant statistic. And then I'm going to talk you through what this confidence interval means and why it is that it means that. So our first step is finding the sampling distribution of our relevant statistic. And the reasoning behind this is that the sampling distribution of our statistic will depend on the true value of the parameter that we're actually interested in. And so we're going to use properties of this distribution to nail down an area that that parameter might be in. Okay? And so once we've got our sampling distribution, what we need to do is to standardize that sampling distribution and then find a standard interval that contains the amount of probability corresponding to the confidence level of our confidence interval. And finally, once we've finished that, we just need to build the confidence interval. This is the easiest step by far. So let's start off with a particular example. These steps will apply to any example that we're given, but in this case, we're going to look at finding a confidence interval for the population mean, given that we know the population variance. And we know that when we know the population variance, well then the distribution of sample means, i.e. the sampling distribution, is going to be normal, with the mean equal to the population mean, which we don't know, and a variance equal to the population variance divided by the sample size. Now in this case, we know what the population variance is, and it's going to be sigma squared equals 6.25. And we also know what the sample size is. We've been given that, and in this problem, it's equal to 49. And so, since we know the population variance and the sample size, well, we know the variance of this sampling distribution. We know that it's normal, but we don't know what the mean is. So now that we've pinned down the sampling distribution of our statistic, our sample mean, there's a few key pieces of information that we need to get out of it. And the one real key piece of information that we need to get out of this is the standard deviation of this random variable. And we know, as always, this is going to be just the square root of the variance of this random variable. And that's going to be the square root of sigma squared on n, which is going to be sigma on root n. But in fact, we know these values. We know sigma squared equals 6.25, and plugging that into our calculator, we're going to get 2.5 as the square root of this value, and we know that n equals 49, and plugging this in, 7. So 7 squared is 49. And we can write this down a little bit simpler. We can write 5 on 14, just a nice neat fraction. And so 2 steps here: find the sampling distribution and compute the standard deviation relevant to that sampling distribution. Okay, so now we need to standardize this sampling distribution, and we know how that works. We simply need to take the random variable minus the mean and divide by the standard deviation. And in this case, it's going to be 5 on 14. And we know this is going to have a standard normal distribution. Okay, and we're going to need to find an interval for x bar which contains, in this case, 90% of the possible values around the true population mean. And so in the case that we wanted a 95% confidence interval, we'd be asking for the interval that contains 95% of the values around the mean of x bar. And so since we've standardized this, we can simply say, okay, I want 90% of the values around the mean of a standard normal, which has a mean 0. As we know from the last tutorial, we can compute this, and it's going to be contained in the interval from plus to minus 1.645. And these are the key figures that we need from this stage. And so the first thing we need to do is standardize our variable. So we've got a nice neat distribution that we know everything about, like the standard normal, or in some cases, a t-distribution. And then we need to find the critical values that contain 90%, or whatever the confidence level of our confidence interval is. In this case, 90% of the values in that standard distribution. And what this is going to tell us is how many standard deviations we need to be away from the mean of this unstandardized random variable to contain 90% of the values around that unstandardized random variable. Okay. And if we wanted to, write an interval that contained 90% of the values, we could do that like we did in the last tutorial, and that would just be mu minus 1.645 times our standard deviation, which is 5 on 14, up to mu plus 1.645 times our standard deviation. And what this is saying is that I've got to be 1.645 standard deviations to the left and 1.645 standard deviations to the right to contain 90% of the possible values in this sampling distribution. And the final step that we need to do is to simply build this confidence interval. And this is really simple. This always works the same way. And in this case, we're simply going to take the value of our statistic. We're going to add this lower bound times by our standard deviation. And that's going to go up to our sampling statistic plus the upper bound times the standard deviation. And in this particular example, well, our sample statistic, we're going to be given that. And in this case, it's going to be 182. This is the mean we recorded when we looked at our sample. And so this sample is going to go from 182 minus 1.645 times 5 on 14 up to 182 plus 1.645 times 5 on 14. And we can rewrite this. We can solve for these values, and they're going to be 181.41 up to 182.59. Okay, and so this is our 90% confidence interval for not the sampling mean, but the population mean, our population parameter. So this is our method for constructing this interval. We find the sampling distribution, we compute the standard deviation, we standardize the sampling distribution and find our lower and upper bounds in our standardized distribution, and we use these to compute an interval around our sample statistic, in this case our sample mean. And what this means is that 90% of intervals created this way will contain my population mean. Or we can phrase this differently and we can say there's a 90% chance that this particular confidence interval will contain my population mean.